Hey class, this is Leonard Rowe. I'm in Group 3 with Cameron Miller and Carlos Aguilla. Our subject was crime in communities where we created the OurBlock mobile prototype. The problem: members of low-income, high-crime neighborhoods often do not have a strong network of relationships in their community. The lack of a strong network limits their access to resources and opportunities. Technology has not been designed for those with low SCS, socioeconomic status, thus marginalizing these citizens. So the question is, how can we design a technology for people of low SES to engage in civil engagement by increasing vertical and horizontal social capital? Our initial research resulted in the findings of two potential competitors in this problem space. Nextdoor and EveryBlock both have a community approach, but requires a great deal of personal information that members of low-income communities may object to. Neither service effectively organizes its members with functionality aimed at community action or connect users with outside members who may have access to resources. Needs. Our goal was to create a community tool capable of connecting members to their community at multiple levels: user to user, user to group, user to institution, user to community resources. The tool was designed to facilitate horizontal social capital through community action and vertical social capital by creating channels of access to members of the community capable of providing resources. The tool should be familiar and have a low barrier of entry to facilitate engagement. Project requirements: a system capable of connecting members of the local community, protect users who wish to be anonymous while facilitating civic engagement, provide a method of identifying, organizing, and executing collective actions, a mechanism for establishing norms through collective governance, must facilitate face-to-face meetings, allow for users to self-identify with the community, and communicate their access to resources such as jobs, training, political engagements. Design must be familiar and consistent with mental models of users with low computer literacy. When designing our storyboard, we thought of one of the scenarios that a user could use our block for. They're in the neighborhood, their car was broken into, so they use our block. They notify other neighbors of the incident, and that incident can be upvoted to bring attention. Um, Other neighbors are aware and they can take the action if necessary. We designed a flowchart to help us visualize the steps our users would take. From here, we figured out the best way to organize the navigation within the app. When designing our lo-fi wireframe, we wanted the functionality to be as simple and easy to navigate as possible. We relied on familiar design patterns to lower the barrier of entry. We included a sign-up page, a dashboard with an activity stream, a neighborhood map with geotagged posts, a profile with avatar and pictures, uh, the ability to search and browse for topics, the ability to create and view posts, and view profiles of government officials. We received feedback for a lo-fi wireframe from Group 4 and our professor. They suggested that the system required too much personal information from the users, addresses and names. System did not give users adequate control of the presentation of their data, how the profile would look to other people, system categories of interest to them. The system did not inform users of their relevant community information, like political representation and how to contact them. And the system was too vague and did not clearly define categories: career, community, and general categories. So when it was time to create our prototype, we kept these criticisms in mind to make our designs more effective.
Here we will provide a walkthrough of our high-fidelity prototype. Our first goal was to connect members to a local community. We achieved this via community selection based on user location and desired community. The pattern used here was geotagging. Our second goal was to protect users who wish to be anonymous. We designed for this goal by providing fine presentation control in the sign-up process and by allowing users to control what they share within their settings. The patterns used here are profile claiming, faceted identity, avatars, casual privacy, profile, and identity cards. Our third goal was to allow users to identify, collaborate in, and organize collective action. Our system allows users to vote on topics to identify the most important issues. The community action page allows for viewing, prioritizing, staging, joining, and executing collective actions. The patterns used here are manage project, upvoting, group moderation, and collaborative filtering. Our fourth goal was to establish norms. We designed for this by implementing downvoting, reputation, and a report abuse function to limit inappropriate behavior. The patterns used here are thumbs up, thumbs down, reputation, report abuse, and community management. Our fifth goal was to facilitate face-to-face meeting. Our community action page emphasizes upcoming events, and event content is generated by community and political leaders. The patterns used here are face-to-face meeting, event creation, and calendaring. Our sixth goal was to give those with access to resources the ability to self-identify and communicate their access to resources to others. We provided flexible sign-up requirements that allow users from outside communities to inform any community of interest. The patterns used here are profile, role model, identity cards, attribution, and recommendations. Our seventh goal was to bridge the social divide. We followed a format similar to popular social networks, emphasized text in actions, and designed an easy-to-follow sign-up process. The patterns used here are welcome area, reflectors, and talk like a person. In conclusion, we feel that we have completed a viable execution of various design principles in designing for the project requirements. Some limitations are the lack of current applications that are designed for the same target audience, lack of understanding of how potential users interact with these types of applications, and a lack of potential user awareness of this type of technology, thus making potential user adoption more difficult. In the future, if given the opportunity, we would like to test this prototype and refine accordingly, and further attempt to create a minimally viable product. Here is the link to our Axure prototype, and thank you very much.